So, my name is Megan Wagner, and the topic that I chose is number 18 about redox reactions. Balance redox equations and include an explanation of how to pick out the half reactions. So, ahead of time before making this video, I went ahead and worked out an example problem that isn't one that the book gives us and isn't like worked out in any of the problem solving, because I thought that the easiest way to explain this would be just to walk through an example problem. So the problem that I chose is to balance this reaction in both acidic and basic solutions. So it's going to be lead dioxide solid reacts with manganese with a 2+ ionic charge that's an aqueous solution to form lead 2+ aqueous solution plus manganese tetraoxide with a negative charge. So the first thing that we have to do is we have to separate it into half reactions based on the ions. So that how we pick out the half reactions is we look at each of the ions. So this one has both lead ions on both sides and manganese ions on both sides. So we know that that's going to be the half reactions that we choose. So to make my half reactions, you keep the products on the product side of the arrow and the reactants on the reactant side of the arrow. So the first half reaction we have is lead dioxide solid to make lead with a 2+ ionic charge aqueous. The second one that we have is manganese 2+ to make manganese tetraoxide with a negative charge. So now that we have our half reactions, we need to balance those reactions with respect to all elements except oxygen and hydrogen. So if I'm looking at these, they're all balanced, so that's just a check mark. They're all balanced except for the oxygen, which that's the next thing we do. So step 3 is going to be to balance the oxygen by adding water, H2O, to both sides. So looking at our first half reaction, we have 2 oxygens on the reactant side, and then we have none on the product side. So we're going to add 2 H2Os to balance that out. Our second half reaction, we have no oxygens initially on the product side, but we have we have none on the reactant side. We have 4 on the product side, so we're going to do 4 waters on the reactant side. Then we balance out the hydrogens by adding H+. So we have 4 hydrogens on the product side, so we have to add 4 hydrogens to the reactant side to make it balanced. And then in this one, we have 8 hydrogens on the reactant side, so we add 8 to the product side to balance it out. The 5th step is that we have to add electrons to each half reaction to balance the charges. So right now what we have is 4 H+, 4 hydrogens with a positive charge, plus lead dioxide to form lead with the 2+ charge and then 2 water molecules. So when we start out, we have a 2+ charge on the reactant side and a 2+ charge on the product side, 4+ charge on the reactant side. So we have to add 2 electrons to the reactant side to make it a 2+ charge to balance those out. Sorry, that's my dog. So sorry. So then on the for the second half reaction, we have manganese 2+ with 4 water molecules to form manganese tetraoxide with a -1 charge and then 8 hydrogen molecules. So we start out with a +7 on the product side and a +2 on the reactant side. So we have to add 5 electrons to the product side to make it a +2 so that everything's equal. Then we have to find a common factor to multiply these by to make sure that these both have the same number of electrons. So right now our first half reaction has 2 and our second half reaction has 5. So the common factor for them is going to be 10. So we're going to multiply everything in the first half reaction by 5 and multiply everything in the second half reaction by 2. So what that's going to give us is the first half reaction is going to be 10 electrons plus 20 hydrogen ions plus 5 lead dioxide forms 5 lead 2+ ions plus 5 water molecules. Right? Yes. Then the second half reaction is going to be 2 manganese with 2 plus 8 water molecules to form 2 manganese tetraoxide plus 16 hydrogen plus 10 electrons. So then we add them all together, and this took 2 lines because it's so long when we add them all together. So it's for reactants, we have 10 electrons plus 20 hydrogen plus 8 water plus 5, that's the lead dioxide, plus 2 manganese 2 plus, forms products of 10 electrons plus 6 H hydrogen ions plus 5 water molecules plus 5 lead with a 2 plus charge plus 2 manganese tetraoxide with 1 negative charge. So we try to cancel out the common factors. So we're going to cancel out our electrons. We're going to have 20 minus 16. So there's going to be 4 hydrogens left on the reactant side. 8 minus 5. So we're going to have 3 waters left on the reactant side. And then we'll keep our lead dioxide, our manganese ion, our lead ion, and our manganese tetraoxide all the same. So this is going to be our final acidic reaction. So the final acidic reaction is going to be the 4 hydrogen ions plus 3 water molecules plus 5 lead dioxide plus 2 manganese 2 plus forms 5 lead with a 2 plus charge and 2 manganese tetraoxide with a minus 1 charge. But so the original question asked us to react this as if it was an acidic reaction and a basic reaction. So to make it basic, we're going to add 1 OH for each H plus to each side to cancel out the new water molecules. So in our final reaction, we have 4 hydrogen molecules. So we're going to add 4 OH molecules to the reactant side and 4 to the product side. What that's going to give us is a total of 7 water molecules, because we'll have 4 plus the 3 that we had. So we'll have 7 water molecules plus 5 lead dioxide plus 2 manganese with a 2 plus charge creates 5 lead with a 2 plus charge, 2 manganese tetraoxide with a negative 1 charge, and 4 OH minus molecules. If you have any questions, you can let me know in the comments below. Thanks for watching.